Welcome everyone. Can you hear me? If you can hear me, please write and confirm in chat. Okay, it seems that you can hear me. Let's then start. Okay, let's start. My name is Raden Kostovic. I work for DV Power as test engineer. Topic of today's webinar is timing measurement of dead tank circuit breakers with both sides grounded. Main reason for testing some high voltage object under both sides grounded condition is safety during the maintenance and testing in high voltage substation. I hope you can see my screen. Okay, safety in high voltage substation is the highest priority for all personnel involved. IEEE standard recommends all objects to be grounded on both sides before any maintenance work is performed over the test object, in this case, the circuit breaker. If the circuit breaker is not grounded on both sides, there are the following risks. The appearance of the induced high voltages and currents from the adjacent energized conductors, the appearance of the advantage electrical potential due to fault occurrence, the appearance of the voltage sparks due to lightning strike. These dangerous voltages can be transferred to the device by the test leads and can threaten testing personnel who is in contact with the test device. Okay, so safety procedure to be performed before starting the maintenance and testing is the following. The circuit breaker is disconnected or separated from its circuit on both sides of the breaker in accordance with the national safety regulations. Then both sides of the circuit breakers are properly grounded to the protective ground, as can be seen in the figures right. Conventional timing test method cannot be applied when both sides of the circuit breaker are grounded. So before starting the test, grounding cable from one side of the circuit breaker has to be removed. I will try to explain the reasons for this through explaining working principles and constraints of the conventional method. So there is shown a circuit breaker connected to one pole of the circuit breaker in the figure upper, in the figure right upper. So as you can see, the circuit breaker is connected to the voltage source of the test device on one side through the one test lead, and to the measurement circuit of the test device on the other side to the another test lead, which connects the test object and the test device. So if the circuit breaker is open, there is no voltage across the measurement circuit, but when the circuit breaker closes, measurement circuit detects the presence of the voltage. So the instant when the voltage appears across the measurement circuit is the instant when the circuit breaker closes. The instant when the voltage disappears from the measurement circuit is the instant when the circuit breaker opens. What are constraints of the conventional method regarding its application to the measurement when both sides of the circuit breaker are grounded? If both sides of the circuit breaker are grounded, beside the main circuit, there will be parallel circuit through the grounding cables and network, as you can see in this figure. Right. Regardless of the circuit breaker state, the device will always detect a closed circuit, since the measurement circuit detects the presence of the voltage always. So that means device will not be able to detect change of the circuit breaker contact state. So conventional timing method is not applicable in the improved safety conditions. So the following test procedure should be applied when test is performed with conventional method for timing measurement. Circuit breaker must be grounded on both sides when the measuring leads are being connected. The ground must be removed on one side of the breaker while performing the timing test. The ground connection should always remain in place on the side on which there is the greatest danger of capacitively or inductively coupled voltages. So there are shortcomings of the conventional method, and there are the following: disconnecting ground connection from one side of the circuit breaker reduces the safety of the test procedure, and also this makes the maintenance procedure much more complicated and time consuming. On the market, there are already test methods for circuit breaker testing under both sides grounded conditions, but they also have some constraints that I'm going to try to explain. All existing BSG test methods are based on the two main methods: dynamic resistance measurement method, which based on the high current injection and voltage drop measurement across contacts can detect resistance change during circuit breaker opening or closing. And the another one is the induction of high frequency voltage across each pole's grounding cables and simultaneous measurement of the current change during circuit breaker operations. So first I will try to explain working principles of the test methods based on the dynamic resistance measurement. For that we have to know commonly values of the resistances which are important for this measurement. Those are the grounding path resistance, which is in range from 7 to 30 milliohms. Main contact resistance is up to 100 microns commonly, while arcing contact resistance is for 500 microns to 10 millions. So the instant when main contact opens or closes is easy to detect, as its opening or closing will cause high changes of the resistance and the current. However, according to standards, the arcing contacts define circuit breaker states, and we will go through that definitions. Okay. So, as you can see, according to IC standard, closing time is the interval of time between the instant of the energizing the closing circuit and the instant when the arcing contacts touch in all poles. And it is shown in one graph here. According to standard, opening time is the interval of time between the instant of the energizing the opening release and the instant when the arcing contacts have separated in all poles. So this is the reason why arcing contacts instant of the arcing contact separation or touch should be detected, not the instant of the main contacts touch or separation. Here is one example. So let's say that grounding path resistance is about 10 millions, while arcing contact resistance is about 5 millions. And the equivalent diagram of that circuit is shown in the figure right in this slide. So the circuit of the the resistance of the tested circuit when main circuit of the circuit breaker is open is equal the resistance of the grounding path, and it is 10 millions in this case. Let's say the circuit breaker, we are considering the circuit breaker close operation. That means circuit breaker is in open position. The generated current flows only to the grounding path. After arcing contact close, the current will start to flow through the main circuit as well. That it will cause the change of the resistance of the tested circuit, and the resistance will change from 10 millions to 3.3 millions, which is the value of the parallel resistance of the arcing contacts and the resistance of the grounding path. So dynamic resistance method will detect instant of the arcing contact touching due to decreasing of the tested circuit resistance at that instant. Voltage drop across contacts will also decrease due to decreasing the tested circuit resistance, and so the moment of the voltage drop decreasing is actually the instant of the contact touching. Regarding the open position, we start from the closed position, and the generated current flows through the main circuit and the grounding path. The equivalent, the value of the resistance of this equivalent circuit is 3.3 millions. At the moment when the arcing contact opens, the resistance changed from 3.3 millions to 10 millions, because when the circuit breaker is open, test device see only the resistance of the grounding path. So dynamic resistance method will detect the instant of the arcing contact separation due to increasing of tested circuit resistance at that instant, as you can see from this diagram right. Current will decrease at the instant due to increasing tested circuit resistance, but voltage drop across contacts will increase due to increasing tested circuit resistance. So the another main method for the both sides grounded timing is based on the high frequency voltage induction. So high frequency voltage induction generator induces voltage across grounding cables. As you can see, it's sine wave AC high frequency voltage generator. So if the circuit breaker is in open position, there is no current to the main circuit and the grounding cables, as you can see. But when circuit breaker closes, current will appear at the instant of the arcing contact touching. Okay. The same way when the circuit breaker open, the instant will disappear at the instant of the arcing contact separation. So applying this BSG method to that tank type of circuit breaker cannot guarantee reliable timing measurement in case of PPN maintenance grounding system, which is very popular in USA market, but only for PN grounding system. So in the following slide are shown PPN grounding system left and PN grounding system. PPN grounding system means that terminals of the circuit breaker from one side are connected to each other first, and then one on them is connected directly to grounding terminal. In the PN grounding system, each pole of the circuit breaker is grounded with a separated pair of the grounding cables. So there are two reasons why these methods are not applicable or reliable in the case of the PPPN grounding system. So there is no separated grounding cables for each single pole of the circuit breaker, which makes it impossible to measure timing of each pole separately by applying high frequency voltage induction method. So as you can see, in this slide, high frequency induction method can be applied for PN grounding system, since there are separated grounding cables for each pole, but it cannot be applied for the PPP and grounding system because there is no separated grounding cables for each pole. Regarding the method based on dynamic resistance measurement, it will not always give accurate results due to interference caused by the voltage drop on the common cables between poles. So when the dynamic resistance measurement is applied, there will be current through the main contacts as well as through the grounding contacts, but also through the cables, but also through the common cables connecting terminals from the one side of the circuit breakers. That current will cause voltage drops, which can then further cause unreliable detection of the arcing contacts, touch, or separation. So DV Power has developed a universal BSG test method that is applicable for all types of the grounding which are used for dead tank circuit breakers. It is based on the generation of high DC current through the main contacts and grounding path, and the measurement of the response signal at the secondary of the current transformer. So as you can see, high DC current is generated parallel to the grounding path, and all three poles from one current source, through these two cables, which further branch into three equal cables to provide even distribution of the current through each of pole. So transition change of DC current appearing during a contact, touch, or separation are transmitted to the secondary of the current transformer and measured by AC probes, which are connected to analog channels of the CAT device, or the circuit breaker analyzer and timer. So even if DC current is generated during contact separation or touch, current will increase or decrease, and it will cause a transmission of the current from the primary to secondary of the current transformer, and at that moment will be used for detection of the contact state change. So this is a equivalent scheme for the PPP and maintenance grounding system, and this method applied on that system. So as you can see, each pole has its own current transformer, separated current transformer. Secondary circuit of these current transformers are used to measure response signal needed for detection, contact, touch, or separation in all poles. These green and yellow lines with resistors present the common cables connecting circuit breaker terminals to the same side, and then one terminal to the grounding connection. As you can see, one current source is used, but current is divided to three equal parts, since both main current cables branch into three equal cables. As you can see, one red cable branches into three equal cables, and this black cable branches into three cables. So let's consider a closing operation first. Let's say circuit breaker is in open position and the generated current flows through the grounding system only, as can be seen in the following slide. If the circuit breaker is open, the generated current from the test device flows through the grounding system and grounding cables. After the circuit breaker contacts close, part of this current will start to flow through the main circuit of the circuit breaker, as can be seen here. That change of the currents or the occurrence of this DC current through the contact is transmitted to the current transformer secondary, and that signal is used to detect the closing time. Example of that signal is shown in this figure. So the instant of the appearance signal of the current transformer secondary is instant of the contact touching. Okay. So let's consider the open operation. That means circuit breaker is in closed position and the current flows to the contacts and the grounding system, as can be seen from this diagram. After the circuit breaker contacts open, the current to the contacts drops to zero. So turning point of the transition signal, which is transmitted to the secondary of the current transformer, is detected as the instant of the arcing contact separation. So these turning points present the instant of the arcing contact separation. So this signal is recorded on the secondary of the current transformer, and it's caused by change of DC current through the circuit breaker main circuit at the instant of the arcing contacts separation. Sorry. Okay. So we also performed the verification of this universal BSG test method. Verification has done in the field, and this is an example of the circuit breaker model, which is used for the verification. It's the tank type of the circuit breaker. GE, its rated voltage is 72.5 kilovolts, 3-pole control circuit breaker, and it was grounded on both sides. This is grounding cables. Here in this figure, grounding cables from one side are shown. And also here are, as you can see, these current cables, which branches. Here are the grounding cables, these yellow from the another side, and these test current cables. Total generated current was about 150 amps. That means about 50 amps per pole and grounding. And of course, maintenance grounding system was PPPN, where, as you can see, terminals from one side of the circuit breaker are connected to each other by these common cables, and then one of them is connected directly to grounding terminal. And we use the conventional timing method for the verification when we removed one side grounded. That means conventional timing method is performed when one side of the circuit breaker is grounded. Here are compared numerical and graphical results for the closing operation for between universal BSG timing method and the conventional timing method. As you can see, closing time is around 70 milliseconds. There are very small deviation between these two methods. So this way we verify that this universal BSG timing method works correctly. Same principle for comparison and verification we use for the opening operation. As you can see, algorithm detected opening time about 29 milliseconds when the universal BSG timing method was applied, and pretty the same results obtained with the conventional timing method with very low deviations, very small deviations, which are about 0.2 or 3 milliseconds. And at the end, verification also was performed for the close open or CO operation, which is shown by graphically and numerical comparison. As you can see, close open or dwell time is about 49 milliseconds for both methods. And this is one more time confirmed that this universal BSG timing method works correctly. Okay. In conclusions, I will list the advantages of this universal BSG test method. Are the following. So this method doesn't require removing the ground connection from any side or pole of the circuit breaker. The above enhances the safety of the test procedure. This method is applicable for any grounding maintenance system, PN or PPPN, of the dead tank circuit breakers. And the connection for this method is simplified since AC current probes are also used for the first trip test, which is performed online before maintenance offline tests. So these AC current probes later can be used in timing test when this universal BSG timing method is applied. That is shown in this figure. So this is diagram when the first trip method is applied. So if you want to record the timing when the circuit breaker is under voltage, and when you want to perform online test, you can connect to the main circuit, but you need to use the AC probes to record chains of the secondary current transformer, which is used to detect instant of the arcing contact separation or touch. So after first trip test is performed, these AC probes, these same AC probes are later used in the these are used for this universal timing test method. You need only to disconnect circuit breaker from its circuit from network and connect the current cables. But you have also connected these AC probes. Okay, that's all. Thank you for attention. If you have questions, you can send them to this mail, which is written here in this slide. But also you can write here in chat. and I will try to answer them.